Hi guys, so today we're going to start 4.3. This is going to be a pretty lengthy section just because there's multiple ways to solve these. But we're going to start off with some definitions. This would be a good place to pause so that you could copy this down for that part one of the assignment that you have this Monday. So we're going to be talking about dividing polynomials, and there's a couple methods. We're going to be focusing on long division, and you've seen that before, and I'll show you some examples so that it kind of clicks back at what that looks like. But pretty much you're dividing one polynomial into another polynomial where it can't equal zero, so a non-zero divisor, and you'll get a polynomial as an answer, and sometimes it'll have a remainder. A shortcut to that is called the synthetic method, but you can only use that when you just have a binomial. We're also going to be doing factoring by grouping. So that's when you split up a polynomial into pairs and then you pull out the GCF of a monomial. And then we have a remainder theorem that says that if you are dividing a polynomial by the x minus k, then the remainder is f of that k. Before I jump into this new stuff, I want to review addition and multiplication because it's what you'll need for your assignment. So part one said that you copied the definitions in your notes, the ones I just went over. You just have to copy that at the top of your page, so it would look something like this once you are done with that part. The second part is about perimeter, area, and volume of polynomials. So I wrote the definitions here about perimeter, the area, and the volume, and I gave you the equations for them. What you're going to do is just follow the instructions, I guess, and find perimeter when it's asking for that area and then the volume. So when it's asking you for a perimeter, remember that it's the sum of all sides of a shape. So here you have this side that is the same as this side, and then this side, which is the same as this side. So I'm not really going to go in depth with this. I did in class with you guys, but you're going to add all of these, and that is going to be your perimeter. So you'll have something like 3x squared minus 4x, that's this side, plus 4x squared plus 5x, plus this side and then this side again. So you'll have plus something and then plus something else. You see that it doesn't fit on mine because I'm trying to write big. So make sure that you have your work somewhere where I could see it. And then at the end, once you're done combining like terms, that is your perimeter. So the perimeter, we're focusing on the sum, meaning addition. With area, we are doing length times width. So the product is multiplication. You'll multiply those two. Luckily, this is a monomial, so it should be rather easy to multiply it into a trinomial or the binomial. On this side, it would just be like distribution. Make sure that when you multiply the exponents with the variables, you're actually adding the exponents together. So if you have x cubed here and x squared, you would add those when you multiply them. And then lastly, it's your volume. And in this case, you're multiplying three monomials together, but it's the same idea as the area. You're just adding an extra dimension into it. For numbers 3 and 6, I would recommend you draw the shape out. Remember that you are adding 4 things when you're trying to find the perimeter of a square or rectangle. So in this case, you want the rectangle, meaning you would add 4 things to give you the full perimeter. And it's giving you that the width is this much, 5x minus 4. So just keep that in mind as you are working. And then this is due Monday. All right, so going into the new stuff, this is going to be section 4.3. Before I start into everything that is long division for this chapter, I want to relate it into something that might look a little bit more familiar. So I'm gonna say, I don't know, elementary school maybe. When did you guys do multiplication division? Maybe elementary school? I know that was a long time ago. So I want to talk about it for a second. Let's take, let's say 252 divided by 7. And I want to solve this using long division. So I am going to take my divisor, which is the 7, and my dividend is 252. So I want to know how many times does 7 go into 252? 7 goes into 2? No. Does 7 go into 25? Yes, it goes in 3 times. 21. I don't think I need to spend too much time doing this. I know it's old, but we should be able to do it. And 0. Therefore, our quotient is 36. We don't have a remainder because 42 minus 42 is 0. Let's look at something else. What about 942 divided by 13? Okay, so I set my problem up. I also went back and I put some terms in here so that you know what I'm referring to when I use words like divisor or dividend. Okay, 13 goes into 94 7 times. 13 times 7, I can do that off to the side, and that would give me 91. So then minus 91, I get 32. So 13 doesn't go into 32. The closest thing I can get is 26, which when I subtract gives me 6. So my answer would be 72 plus that 6 that is left over the divisor, which is 13. And this part here is our remainder. And this is going to be really important when we're doing polynomials. So you take whatever is left over, and that becomes your numerator, and then your denominator becomes your divisor. So let's look at something that has to do with high school now. That was a little bit going back a while. All right, so jumping forward to Algebra 2 now, which is where we're at, let's look at this trinomial divided by this binomial. Now, I know this looks a little overwhelming, but let's start with what we know. We know how to set this up. We set it up for this, so let's set this up the same way. We have x minus 5, and then we have 3x squared minus 14x minus 5. When we are doing these, we are focusing on the term that has the variable, and we are asking ourselves, how many times does that go into the biggest term that we're dealing with, and in this case, that is 3x squared. So, how many times does x go into 3x squared? Well, we need a 3, and we are missing the x. So if I were to multiply 3x by x, I should get 3x squared, which is what I want. So I do it to the x, but I also need to multiply it by the minus 5. So here I have minus 15x. Here I am going to subtract. But if I'm subtracting this whole thing, when I distribute, just like we have been doing, this would end up into a plus. So now I have negative 14 plus 15x gives me x minus 5. So how many times, so now the x that I'm dealing with is this one here. How many times does x go into x? one time. So 1 times x is x. 1 times minus 5 gives me minus 5. I subtract, which would turn this into an addition, and I would have 0 remainder. So my quotient, my answer would be 3x plus 1. All right, so I'm going to give you one to practice now. Okay, so now I want you to practice this one on your own, following the same steps that I did. I'm going to give you guys some time. You can pause here to answer. Okay, so this is how I solved it. I set it up in pink and then I went through. Now, it gets a little bit tricky here because we know that when we subtract, it's going to change the sign. So here it canceled this one out. When I moved it over to this plus, when I distribute it, it turned into a minus. So that's why I put that minus sign there. Same thing down here. A 3x plus a 4 does give me a plus 12, but when I do that subtraction, it turns it into a negative, which is why I end up with a negative here. And then in the last one, it switches all the signs over so that I have a remainder of 0. Okay, what happens if we have this? Now at first look, it looks like the same thing we've been doing. So let's go ahead and set it up. X minus 4 is our divisor, and our dividend is x squared plus x minus 17. I am focusing on this x, and that's what I will be trying to get here, trying to divide into. So x into x squared, I get an x. So x times x is x squared minus 4x. I'm going to subtract, which turns it into a plus, and then I get 5x, bring this down, minus 17. How many times does x go into 5x? Well, a positive 5. So then I get 5x minus 20. Subtract, which would turn this into a plus, and I would get 3. So then this 3 becomes part of my remainder. I'm going to take my binomial x plus 5, which is our quotient. And then if you remember the first one, when I did at the beginning, I did one with the remainder, where we said that our remainder over our divisor is our remainder that we add to the back. So I'm going to take this, I'm going to say plus 3 over x minus 4. And that is our answer. The idea is the same. It just happens that instead of having a number like 13, now we have a binomial, which is x minus 4. So before we turn it into something a little bit deeper, I want you guys to go ahead and try this one on your own. Go ahead and pause the video here and work on solving this one on your own. Okay, so this is how I did it. Again, I'm getting the x into the biggest one that I have here. X squared, I moved it down. When I distributed, this plus became a negative. And then when I combined them, I got negative 8. So now I want to know these two, and that's how I got that negative 8x. I continued all the way to the end until I had a 1. So remember that that goes over this here, and that becomes my remainder. So I took that trinomial that I had as my initial quotient, plus the remainder, which is 1 over the divisor, which is this. And you should have that as your final answer. Okay, so you may have noticed I changed the color because we're going to go a little bit deeper now. Um, the first thing that I want you to notice here is that we're dealing with bigger exponents. Here is a 5. The last few that we did, the biggest that we had was a 3. Another thing I want you to notice is that instead of just having like the x plus 6, now we have 2x something. So everything just got a little bit bigger. Before I start though, I want to point something out, and it's really, really, really important for you to notice this. My exponents are going 5, 3, 2, 0. When I write this over, I need to make sure that I have an exponent. I have a term for every exponent. Now, that might be a little bit weird to think about for a second, but I'm going to do 2x minus 10, and this is where my little house is going to go, 2x to the power of 5. That's going to be my biggest one. I am missing my 4, so what I'm going to do is I'm going to fill that spot with a 0. Anything times 0 is 0, so it won't affect my equation, but I do need that placeholder. Negative 34x cubed minus 84x squared. Now I'm missing my x, so I'm going to do the same thing. I'm going to add that placeholder for the x, and then my 110. Make sure that you guys use your placeholders for every exponent that is not written in your initial equation. From here, we do the same thing. So I'm going to focus on this, and it should be the same thing that we've been doing. So I have the 2, I have 1x, I need 5, so this is going to be x to the 4th. Minus 34x cubed. So again, I'm going to focus on those two things. So we got 10, 4. Okay, so that would give me 16. All right, so you see, I'm just going on and on here, so that would turn into a plus there. Now, I know that at the beginning, those terms looked a little bit scary because they're big, but you notice that when I'm dealing with them, I'm actually getting something that isn't that bad. So like a negative 4 isn't as bad as I thought I would have with a negative 84. So it's not that bad. Okay, so now I have this. I forgot to do it to this one. So negative 2x give me negative 4x squared plus 20x, because a negative times a negative would give me this positive. Okay, so that would be a plus, which would cancel. Now I have a negative 20x, and bring down my 110. Let me zoom out for a second. I know this is getting pretty long, but it was important for me to show you the placeholders. So then minus 10, negative 20x plus 100, because a negative times a negative, which would actually be a negative, so now I have a 10. So my answer would be x the power of 4 plus 5x cubed plus 8x squared minus 2x minus 10 plus 10 over 2x minus 10. I want to, again, and I talk about this in class, the difference between something being long and tedious to it being actually difficult. I don't think that these multiplications, adding and subtracting things, are difficult. It's what we've been doing for 2 weeks now. But it is, I understand, a little tedious to have to do this so many times. I would definitely encourage you to be as organized as possible when you do this, because you can see that since it's a lot of work, it can get messy really fast. And that's where you start dropping negatives by accident or making small mistakes. All right, now it's your turn. So just like we did the last one, go ahead and solve this one. If you think that you need to review the other one, go ahead and rewind it. Maybe even pause it where all my work is done so that you can do this one on your own while looking at the other one. Or try it all by yourself. Go ahead and do this one, please. Okay, so this one was actually really short. Now, you may have started and you may have thought that you were doing something wrong. So let's just go through it. I got my 2x to the power of 5. When I multiplied, I got minus 3x to the power of 4. But since I'm subtracting, I multiply that in and it turns into addition, which goes to 0. So at first I started with my 0. But when I brought the next one down, I noticed it would also be 0. And then I brought the next one down, and it was also 0. So there's nothing that I can multiply by 2x to give me zeros. So I just kept bringing things down until there was actually something I could work with. So it was those last two terms, 4x minus 8. And that's how I got that too. When I got it, I ended up with this. So my answer would just be x to the power 4 plus 2. I'm going to ignore all of the zeros because they're just 0. Now, instead of plus something, I'm going to say this is minus, because it's that, 2 over 2x minus 3. And that's it. So I think that a good one for you to review would definitely be this one, because this includes everything that we just covered with division. Let me go ahead and zoom out, and I'll leave this here so it could be a good place for you to pause and just kind of try to grasp everything, try to process this whole process. All right. Good luck.